Good afternoon, everybody, and welcome to our next lecture in our little series on utilizing Mplus to do your analysis. So I've decided to do something a little bit different. I thought it would be more interesting and a lot more convenient to kind of integrate some of the theoretical aspects of my presentations, of my tutorials, into the practical ones. So if you are very familiar, for example, with this topic on moderation, just skip towards the end and the analysis section will be there. So today we're going to be talking about how do we compute moderation or interaction effects in Mplus, and what is this moderation stuff all about? So moderation is basically nothing more than a nice way of saying it depends. Or it depends on. So think about the next example. I'm not a vegetarian, but some of you probably are. You like Brussels sprouts and I don't. So you enjoy it a lot and I don't. So if we wanted to see how does consuming Brussels sprouts affect enjoyment of eating, so a relationship between X and Y, eating Brussels sprouts and having enjoyment, a factor that will influence that is definitely our preferences for our eating preferences. So if you're a vegetarian, that will impact how much you would like this relationship. For me, it will decrease it because I hate it, and for you, it will increase it. So if we added, for example, I don't know, bacon to the equation, then bacon to Brussels sprouts, my level of enjoyment would increase significantly. But as a vegetarian, you might not necessarily like that. And that's kind of what moderation is. So if we basically say, what's the relationship between eating Brussels sprouts and, I don't know, a level of enjoyment? What does it depend on? It depends on a third factor, which is our eating preferences. And that's basically what moderation is all about. Moderation really occurs when we have a relationship between an independent variable, right? So in this example, for example, depression, and we have a relationship with it with performance. So we know that higher levels of depression leads to low level of performance. However, the strength of that relationship is largely impacted or affected by your social support network, right? So high depression equals low performance, but if you have a very high social support network, a very large one, you've got lots of friends, lots of family, your performance is not necessarily going to be affected that much. Whereas me, that has no friends, it means that my depression is really going to affect my performance negatively. Okay, so that's kind of like just an overall idea of what it is. Fundamentally, though, if we think about it statistically, moderation really is present when we have an interaction effect between depression and social support, between our independent variable and our moderator. And if this interaction between these two factors positively or significantly, not positively, significantly affects performance. So the model you see in front of you is kind of how we depict moderation, right? We've got a relation between two factors and something impacts that relationship. However, the last statement I just made about the interaction effect, it's perhaps better to show you how the model looks like in statistical terms. So the statistical model gives a more accurate representation of what we're actually testing from an equation perspective. We have depression predicting performance, we've got social support predicting performance, and then an interaction effect. And that's basically the product of depression and social support. So our depression times social support creates this interaction term. And this then predicts performance. So if there is actually moderation present in this model, then this interaction effect would positively predict performance. And then we can plot it in a very nice and simplistic way. Now, there are, however, a couple of assumptions that we need to take in consideration when we want to assess moderation. So the first one is that our independent variable and our dependent variable, they always need to be independent, right? So they need to be separate from one another in the best case scenario, also measured at separate times, right? But they need to be totally independent of one another. So no multicollinearity. So our dependent variable needs to be measured on a continuous scale, right? So whereas our moderator and our independent variable can be dichotomous, it can be binary, it can be a count variable, it's important that our outcome variable is rated on a continuous scale. So think Likert scale 1 to 5, or the net performance score, that net promoter score, it rates everything on a scale of 0 to 100. So it needs to be on a continuous scale. Only then can we estimate moderation. Then, as with any other multivariate statistical technique, the same functions and assumptions apply. Firstly, no skewed data. So it has to comply to the requirement of multivariate normality, right? So skewness and kurtosis smaller than -2 on big samples and smaller than -1 on small samples. There needs to be, again, a positive, not necessarily positive, but a significant relationship between all of our factors, really important. And a new requirement is that our independent variable and moderating factors need to be centered. In other words, it has to have a mean score of 0 and a standard deviation of 1. Why? Because it helps us to interpret the data just a little bit better. It helps to plot it better. Although Preacher and Hayes kind of said that it's not necessary to standardize factors anymore, if you want to compare things directly with one another, standardization is unfortunately the best way to go. So always standardize the independent variable and the moderator. So it has a mean of 0 and a standard deviation of 1. Also, there should be no multicollinearity. So in other words, relationships between factors should not be larger than 0.9. And all of the outliers that we have in our data set needs to be removed. And this is also a function on how to ensure that our data is in fact normally distributed. And then finally, if all of these things are in place, we want to create an interaction term. And like I mentioned before, this interaction term between our independent variable and our moderator needs to predict our dependent variable positively, statistically significantly, not positively. It can be negative as well. So there are basically then two approaches towards estimating moderation. There is what we call continuous moderation, which can be between latent factors like here, or it can be between just observed factors, so mean scores. Or there's the multi-group approach, where we basically look at the relationship between two factors and see if it's different from each other. For example, in this case, between males and females. Maybe it's easier to look at it this way. So it's perhaps easier to look at it as what's the relationship between depression and performance for males, and what's the relationship between depression and performance for females, and is it the same? So that is another way to kind of estimate moderation. Now, there are basically 6 steps that we need to take in order to get us there. The first one is that we have to test if our independent variable and our moderator actually predicts our outcome. So in this case, for example, does happiness and person environment fit, does it predict performance? That is our first assumption. The second assumption is that we have to center or standardize our independent variable and moderator so that it has that mean of 0 and variance of 1. So after this is done, we create our interaction term. So we create a new factor, call it whatever you want. I always just call it interaction. And that's a product of, that's a function of the independent variable times the moderator, right? If this is in place, then we put all of these things into our model and we try and see if our independent variable, moderator, and interaction term now predicts our dependent factor, right? If our interaction term then predicts our dependent variable significantly, then we have moderation. And if we have moderation, then we can start creating those nice plots that you see on the internet. Okay, so these are the 6 steps. Test if the relationships are there, standardize or center the variables, create an interaction term, put all 3 new variables into your regression equation, and test if they're significant. If the interaction term is significant, there's moderation, and if this is the case, we can create our plots. So let's go and test this in Mplus. So we want to look at the relationship between person-environment fit, task performance, and happiness, right? We want to see if happiness moderates that relationship. So if people are high on happiness, does it affect the relationship between person-environment fit and task performance? Okay, so let's jump over to Mplus. Okay, so this is our syntax, and we're doing this all with latent factors. At the end, I'll do one with observed indicators so you can see. But so far, nothing on the syntax has changed. So far, the variables are the same. All the variables we'll use is the same. But now we create a new thing. We add a section called define, so the define command. And in the define command, we want to standardize our variables. Now, it's easier to kind of just standardize the items in this case. So we are standardizing all of the items of our independent variable, which is person environment fit, and our moderator, which is happiness. Okay? In the analysis command, we add two new factors. We add the type of analysis, which is general and random, and the algorithm that we're utilizing is the integration algorithm. So this is the two things that you add extra. Then our model basically stays the same, our measurement model. So this is our best fitting measurement model. And you know how to do this already by now. But now we get three new things in our model. The first thing is we have to create that interaction term, right? And if we had observed factors, it would be easy. It would be task before happiness times fit, and we have a new factor. But because we're working with latent factors, we have to utilize the x with statement within Mplus. So we create a new factor called interaction, or whatever you want to call it, and that is a function of our independent variable and our moderator. So always new variable name, fit, independent variable, x with happiness. Straightforward? Excellent. Now we go to our structural model, and it's important to kind of split this out in step-by-step form like I've done here. So because we have to give each one a specific label, and it has to be in this order, by the way, so you can utilize the next part for the plots. So task performance is regressed on person environment fit, and I label that as B1. So my independent variable is labeled as B1. Task performance on happiness, B2. B2 is my moderator. Task performance on the interaction term, and this is the thing we're interested in, that is B3. Now you can label this whatever you want, doesn't matter. Just as long as you're consistent, because you have to utilize these little terms in the next part of our syntax. Now here is where it gets a little bit complicated, right? So this part we use as a means to help us to create a plot in Mplus. So we use the model constraint command, and we basically say we want to have a new function, and this new function that we want to have low moderation, so people low in happiness, average levels of happiness, and high in happiness, right? Then we want basically the simple slopes for low levels, medium levels, and high levels of our factors. This part, because we've already centered our factors here, right, so it's standardized, we know that our mean, which is our middle point, is 0, and our lowest part that you can possibly get is 1, and the highest is 1, minus 1 and plus 1. If you did not center it, you will have to use the physical mean score of your items and the physical mean score standard deviation of your factors here. But standardized just makes it a little bit easier. Then we create an equation for our simple slopes, and it's basically y equals mx plus c, right? Standard. So the simple slopes for low is then our independent variable that is a function of our moderator and the new factor that we've created, right? So you don't have to worry too much about this. If you keep the labels the same, you don't have to change anything here. This last part is the part for the plot. Now I know that my x factor, the range of my x factor, for example, Because we standardize it, I know that it can't be higher than +3 and -3, and I want the plot to come out at points of 0.1. So I want that small little integer change over time. And this is basically just to create the moderation effect. Now if I click run, oh, last thing, the plot that we want is plot 2, because this plot gives us the interaction effect and the confidence intervals, and because we indicated integration and general, we can ask for confidence intervals. Okay. Let's see. So the data has run. This is just an input error because it's too long. We look at model fit. Now, because we standardize this, we have to look at the model results and not the standardized model results, because this will not be standard, but the factors that we did will be. Okay, so this will be standardized. What we are interested here is, remember, we wanted to have a positive, a significant relationship between our interaction effect and our outcome. Is this significant at a p-value of 0.05? No. Is that significant? No. Therefore, this already gives us a bad feeling about moderation. So there's, according to the first step here, no moderation. But this is not the only thing we want to talk about. We're also interested in the confidence interval change, just like in mediation. So we look for our estimate. Our estimate is then here, and it's the same value as before. Minus 0.158 is the same value as the estimate here. Where is it now? See, it's exactly the same variable. We are just interested in the confidence interval change. I'm just going to do this so it's easier for us to see. So we want to kind of like see at the 95% confidence interval change, does the lowest part go through 0 to the highest part? So if we look at it, it starts at minus 4.8, goes all the way through to plus 0.174. So unfortunately, this also tells us, because it includes 0, so it goes from minus through 0 to positive, there is no moderation. But we can also look at the plots. So we scroll down and we just want to make sure there's no errors there. So we can ask for the plots. To get the plot, we click on View Plots. There will only be one. We only want the one at a time here. So this one will be for low levels of happiness, low moderation. And here is the blue lines are our confidence intervals, and the red line is our actual estimate, right? So we can clearly see that the lower confidence interval at 3 is like minus 9, 1.9, and plus 0.7, and the same here. So that tells us there is no moderation. But let's say, for example, there was. So if we only estimated from the mean score, so from 0, so ignoring this part, just for argument's sake, we would see that there is a positive interaction. So people, for example, that are high on happiness or low on happiness, their levels of performance will increase significantly, right? So the relationship between person environment fit and performance is then moderated by that factor. Unfortunately, in reality, as you can see here, it's not, but that's how you would interpret it. At the lower end, people on the high end, the mean score, for example, this is just the average mean, again, also non-significant, but there is some other trend at least present. And we can see at the high level, so people high on happiness, it seems as though people high on happiness will have lower levels of performance for some other reason. If it was significant, which it's not, but there is some trend there. So to go back to our results, again, our model results tell us that the estimate are the same. It's negative, however, unfortunately it's non-significant, so there's no levels of moderation. The next step that we test is looking at the confidence intervals. Does it include 0? It does, unfortunately. So the second assumption, or the second test that we can use, is non-significant, and then we look at the different plots. The plots, non-significant, confidence intervals, non-significant, and so on. And therefore, from that perspective, we know that happiness does not moderate that relationship. The next approach that I want to show you is the multi-group approach towards moderation. So here we're going to look at the relationship between person, environment, fit, and performance, but we want to see if gender impacts that relationship. So if you're males or females, how does it affect the relationship between these two factors? Okay, so let's go to Mplus. Now, interesting, we are doing multi-group moderation with gender as a observed indicator. Okay, so this is a lot simpler than the previous one. So the only thing that we're adding here extra is that we're adding gender in our use variables command, and we're adding a grouping statement. So we want to tell Mplus in gender what are all the ones and what are all the twos. Here, all the ones we tell it is males, and all the twos are females, right? So in our model command, we have our overall model, which is our normal person, environment, fit on task performance. I just reduced the amount of items there just to make it more simplistic. And I correlated this error term to improve fit a little bit. So then we have to specify the same thing for model male and model female. So exactly this model, task performance, anything that we do extra, we have to estimate there. So here, this is the relationships, and you can call it whatever you want. I just called it males. You can say A or B, because we're giving it a label here, this relationship, so that we can test it against each other at the end. We do the same with models female, where we say task performance on fit, and we just give it that label. Now here is where the crux is of the matter, the thing we actually want. This is how we assess the Walt test, to look if there is a statistically significant difference between these two factors. If there is moderation, then it would be non-significant, right? So let's run it. This warning just tells me that there are some factors where people did not indicate their gender, which is fine. Fit is good, it's the first thing we check, although SRMR is bad. And Ramisa is also, it's lower than 0.8, but we can still tinker with the model a bit to get it fit. But for argument's sake, let's just keep it as is. Chi-square, this is the amount of contribution of males and females to this chi-square, right? So females, because there's also a lot more females in my data set than males, so of course it makes sense that they attribute more variance. This is important. So here you can see it's non-significant, so there's a non-significant difference between the two, so they're the same, which we'll get to in a minute, but this basically tells us that there's no relationship between the factors. There's no moderation. We're going down to the standardized results now, and I'm just going to delete this just to make it easier. Okay, so we look at the standardized estimates. They are all significant, right? The relationship between fit and task for males is 0.3, for females is 0.24. There is a difference, you can see it, but I don't think it's that strong. And the Walt test tells us that it's not significant. The interesting other thing is that the mean score here was 0, and here it tells us that females scored slightly higher on person, environment, fit. Slightly higher, but non-significantly. Okay? So long story short, this tells us that we have no moderation. Okay, so if we can go back to, just to summarize, this is our estimates. You can clearly see that the factors are loading significantly on each other for both groups. However, there is a non-significant difference between the two. So they are basically the same. And you can see that 0.24 is not that much different from 0.39, given that the standard error here, for example, is so high and there, right? And because there is no moderation, there's also no difference in the mean scores. Okay. Follow me? Good. The last way is that we're going to do the same thing with the same factors, but this time instead of utilizing latent variables for personal environment fit performance, we're just going to use mean scores. We're just going to use observed indicators, just to show you the other way to kind of estimate it. So now it becomes again a little bit more complex. So in our define command, we are doing three things. We are creating mean scores. So the mean score for task performance is all of the factors divided by 7. For fit, it's all of the factors divided by 3, because there's only 3. This is the same. You could have also created mean scores in SPSS, or you can use these scores directly, but it depends on what your question is. So now we create an interaction term. That's the second thing we do here. And the interaction term is our independent variable times our moderator, right? And now what we do is we're standardizing the mean scores. So we're standardizing these factors so that it has a variance of 1 and a mean of 0. We're just saying type is general, and now our model command becomes a little bit different. So here we basically are creating our null model in this equation. And as with the other steps, first one, task performance on fit, so task performance on my independent variable, I give it a label. Task performance on my moderator, I give it a label. And task performance on my interaction effect, I give it a label. Now, unlike in the previous one, here we want to tell Mplus what is a low value and a high value. So I know my for your moderator, right? My moderator only has two factors, a 1 and a 2. So males and females. So I'm just saying low will be 1 and high will be 2. So males and females. Same thing, we just create the equation for the slopes, and then we basically ask it to generate the plot via the loop command for us. So we want it on our x variable, which is basically person environment fit, and we basically want it at 0.5 intervals. And we know that based on our rating scale, because person environment fit was rated on a scale of 1 to 5, 1 being low and 5 being high, that's all I'm putting in there. Same thing as last time, we're asking for plot 2, and we want this time confidence intervals, but we want bias corrected, bootstrapped confidence intervals. Okay, click run. This will come up. You will see, because I specified the bootstrap command here to be 10,000, it's going to run for 10,000 of these little things. So again, there's some factors missing, which is, we know, model fit is perfect. But this is kind of what we are interested in. Because we standardized the factors before, we look at the normal model results. So again, we look at the significance value. So the important thing here is that our significance value for our interaction effect is non-significant, as is everything else. So that already tells us, again, it just confirms that we have no moderation, right? It doesn't impact it whatsoever. We go down to our confidence intervals. So we're looking at the standardized. So this is our estimate, 0.06. Here you will see it again, right? And at the lower level, the 95% confidence range, it starts with a minus, it goes minus, minus, plus to the top 95%, and therefore we know, as I said before, unfortunately, the confidence interval does include 0, so no moderation. But we can also look at the plots. Now these plots look a little bit better. So I'll first do it individually. So here you can see that the plot for males, right? The confidence intervals are non-significant, but the plot shows us that there is a positive trend. For females, there is a similar trend, right? So there is no moderation, so the relation between the two things are pretty much the same. But we can also look at it together. So we can ask for plots, but this time I say I want to have all of the things, males and females, together. So here are the two dark lines. So the dark blue line is females and the dark red line is males. And here you can see it has a similar trend, right? So there's no interaction whatsoever. So it does not moderate. It goes up on the same slope. But what we can kind of like say is that if there's no difference in terms of males and females in the relationship between person, environment, fit, and performance. In other words, it does not moderate. It does not impact. Whether I'm a female is not going to impact if the match between my job and my life, my job and my person, if it's quite high, it's not going to affect my performance that much, whether I'm male or female. Okay, so just back here. Again, just a summary, you'll see this confidence interval range does include 0, so no relationship, and these estimates are the same. Those are the things. So, for homework, I'm going to ask you to take our data set and determine whether emotional well-being, which is made up of mental health continuum item 1, item 2, and item 3, if this latent factor moderates the relationship between person, environment, fit, and task performance. So test that, the memo is available, and let me know what you find. Ladies and gentlemen, I really hope that you found this presentation meaningful, and I will talk to you again next time.